Hello guys, welcome back to my channel. My name is Sanket and in today's video we are going to cover everything about modern software development. And in this particular video we are going to cover what is software development lifecycle. We are going to see different traditional software development lifecycle models, agile methodologies, DevOps methodology and case study of Instagram application. So before we jump into the Git and Python tutorials, we need to understand what is software and how this software is actually being created. So without further delay, let's get started. So this is the course outline. In lesson 1, we are going to understand the modern software development. In lesson 2, we are going to cover challenges with traditional SDLC models. SDLC stands for Software Development Lifecycle, and we are going to use this abbreviation in this whole video. In lesson 3, we are going to cover introduction to DevOps. In lesson 4, we are going to learn about the role of DevOps methodology over traditional software development lifecycle models. In lesson 5, we are going to cover DevOps tools and technologies, and we are going to end this particular video with lesson 6, and we are going to cover Instagram as a case study of DevOps for this particular video. So without further delay, let's get started with our lesson 1, that is understanding modern software development. So in this particular lesson, we are going to cover introduction to software development lifecycle, and we are going to go through traditional software development lifecycle models that are available and that were used in 90s. Introduction to software development lifecycle. So before deep diving into what is software development lifecycle, we need to understand what do you mean by software. So software is nothing but a collection of instruction, data, or of computer programs that are used to run machines and carry out particular activities. So we use different application on a day-to-day basis to perform various activities, perform various things as per our requirement. So we call it as a software. So in order to build that software, we need to perform the software development process. So software development is defined as process of designing, creating, testing and maintaining computer programs and applications. And in order to create that software, we have to perform some standard models that are available in the industry. So software development lifecycle can be defined as process used by software developers to design, develop, test, deploy and maintain software systems. It's a systematic approach to a software development, ensuring quality control and organization. The purpose of software development lifecycle is to create high quality software that meets or exceeds customer expectation within the defined timeline and budget. The 6 core phases of software development lifecycles that are present in each and every software development lifecycle model are as follows. First one is planning, second designing, third one is development, that is nothing but a coding, fourth one is testing, fifth one is deployment, and sixth one is maintenance of that particular software. Each phase focuses on a specific aspect of development, from planning to maintenance, ensuring all project goals are achieved. So this is all about introduction to software development lifecycle. In next slide, we are going to cover traditional software development lifecycle models. To begin with, we have waterfall model. So waterfall model is a traditional model which was used in 90s to create applications, and it follows a sequential linear development model where each phase must be completed before moving to the next stage. It's a simple and easy to understand model, but it lacks a flexibility where changes are needed. in the development stage, if your client has a specific requirement, or if your client want to update any specific requirement, then that was not possible with the waterfall model, due to which it was not really used in production scenarios. Next one is V model. So it is similar to the waterfall model, but with an emphasis on verification and validation. Testing is planned at each stage and defects are caught early in the development. So let me quickly show you how V-shaped model looks like. So this is waterfall model and it follows a sequential linear development process. So it starts with gathering requirements, then performing the design of application, then it starts with, based on that design, developer starts with the implementation of that application. After implementing the application, next stage is to perform the verification of that application, and then further perform the maintenance of that application based on that verification and validation process. So this is about waterfall model. In V-shaped model, at each stage validation is done. So after gathering the requirements, the validation is done. After performing the system analysis, the validation is done. After creating the software design, the validation is done. After model design, validation is done. So at each stage, validation is being performed in V-shaped model. So this is all about like V model, and testing is done at each stage. Next one is incremental model. An incremental model involves breaking the software development process into smaller manageable segments. Each segment is developed and tested independently before integration into larger systems. So here you can see incremental model, and your requirements are being segregated into multiple segments where each segment is developed and tested independently before integrating into larger system. Fourth one is a spiral model. It follows a iterative development with risk analysis and management, where development is conducted in repeated cycles or spirals. It is suited for complex high risk project, and it is not really been used in the industry. Next one is agile model, and agile model is a flexible, iterative and incremental development model. Agile promotes continuous improvement, collaboration and flexibility to meet changing user needs. Each model has its pros and cons. For example, waterfall model is rigid and it doesn't allow changes once the development starts, while agile is adaptive and it allows for frequent changes based on user feedback. So in the modern era, agile and DevOps are often favored due to their flexibility, speed and focus on delivering continuous value to the customers. And here you can see the agile model, which is kind of having a similar methodology as DevOps. Up next, we are going to see the challenges with traditional software development lifecycle models. So in this lesson, we are going to cover limitations of waterfall model and V-shaped model. And we are also going to learn why DevOps is a better solution. So limitation of waterfall model and V-shaped model. So first one is waterfall model, and the first limitation of waterfall model is inflexibility. As you know, waterfall model is rigid and it follows a sequential process. It's hard to make changes. Second limitation is delayed testing. Testing is done after the development phase. So which means bugs and defects are discovered very late during the whole software development process. Third limitation is its slow response to change. So the model is not adaptable for fast changing requirements or market conditions. So these are the limitations of waterfall model. Next one is V-shaped model, and the first limitation is limited flexibility. So like waterfall model, the V-shaped model is also sequential and it can be costly when adjustment need to be made. Second one is late validation. So even though it emphasizes early testing, it is still a linear process, means problems in later stages may still be too complex to fix efficiently. So these are the limitations of waterfall model and V-shaped model, because of which the modern day applications are well suited with DevOps methodologies. So why DevOps is a better solution? So traditional SDLC models, particularly waterfall and V-shaped model, fail to address the need for flexibility, speed, and continuous feedback in modern software development. So DevOps is more suited to the fast-paced tech environment where change is constant and there is a need for quick iterations and continuous user feedback. So let's deep dive into DevOps. And so next lesson of this particular video is introduction to DevOps. And in this particular topic, we are going to cover what is DevOps and core practices in DevOps. So let's understand what is DevOps. So DevOps stands for development and operations. So it is a culture and set of practices that brings together development team and operations team to work collaboratively and automate the software delivery process. This is the life cycle of DevOps, and each stage has its own purpose. So it starts at planning stage. So this whole DevOps life cycle starts with planning stage. So planning stage defines the requirements, features, and project scope. Teams plan development and operational processes collaboratively. Next stage is code stage. So in this stage, the developers write code for the application, ensuring continuous integration and testing to detect the errors early in the stage. Third stage of this particular life cycle is build stage. So in build stage, code is being built, packaged, and prepared for the deployment. This process or step includes automating build process using continuous integration tools like Jenkins, Circle CI, GitHub Actions, etc. The fourth stage in this particular life cycle is test stage. So in this stage, automated test cases are run to ensure code quality, security, and functionality. Issues are detected early and fixed before the deployment. The fifth stage is release stage, and code is being deployed to a staging or production environment. Continuous delivery tools ensure the process is smooth and automated. The continuous delivery tools like Jenkins comes into picture at this release stage. Sixth one is deploy stage. So your software is released to production, often using continuous deployment tools and infrastructure as a code to provision necessary environments. The seventh stage of this particular life cycle is operate. The application runs in a production environment monitored for performance, uptime, and security. The next stage is monitor, and the monitor stage is responsible for continuous monitoring of your application to be done to gather the feedback of application performance and detect issues in real time. And based on this monitor stage, the feedback is generated. So the next stage of this particular life cycle is not mentioned in this particular diagram, but the next stage is feedback and continuous improvement. So based on monitoring and user feedback, improvements are made and this cycle repeats for further optimization. So this is all about DevOps lifecycle, and it ensures that the end customer will get the software product as per their requirement. Next thing is the role of DevOps over traditional software development lifecycle. So how DevOps improves the overall software development process? So DevOps ensures the faster delivery of the application. It automates the processes for quicker deployment and more frequent releases. Second, improved collaboration. So DevOps breaks down silos between development and operations team. Third is higher quality. So continuous testing and integration ensures higher code quality and fewer bugs. Fourth one is scalability. Infrastructure automation enables consistent scaling and faster provisioning. Fifth one is faster feedback. So continuous monitoring and user feedback help improve applications in real time. Sixth one is enhanced security. So DevSecOps integrates security into every stage of development. Seventh point is efficiency, and DevOps help reduces manual efforts, manual tasks. It minimizes the errors and it optimizes the workflows. Up next, we have commonly used DevOps tools and technologies that are popular in the market. First one is version control. So in order to store your software in a remote location or in a central location, we have a version control system, and most commonly used tool for storing your code is Git, and we use SCM tools like GitHub, GitLab, Azure repos, etc. Next one is CI/CD tools. So Jenkins is widely used and well known tool for CI/CD. People also use GitLab CI, Circle CI, Azure DevOps, GitHub Actions, GitLab Actions, etc. For configuration management, Ansible is widely used. For containerization and orchestration, Docker, Kubernetes, and Helm is widely used in the market. For monitoring and logging, Prometheus Grafana is used. For logging purpose, ELK or EFK stack is used. For APM application monitoring, Dynatrace is widely used tool in the market. For infrastructure as a code, Terraform is the well-known and widely used tool. For collaboration and communication purpose, Slack and Microsoft Teams is widely used. For agile methodologies, Jira and Azure DevOps is widely used. Cloud platforms. So top 3 cloud platforms are being used across the industry, and AWS, Microsoft Azure, and GCP. These are the 3 clouds which are widely used in the market. Security. To implement security in your DevOps lifecycle, you need to know SonarQube, you need to know HashiCorp Vault. So SonarQube and HashiCorp Vault are widely used tools. For testing purpose, you can use Selenium, JUnit, TestNG, Cucumber, etc. Artifact repositories. So Nexus and JFrog Artifactory are quite commonly used. For build automation, Maven is widely used for Java-based application. Gradle is used for Android-based applications. And these are the commonly used tools and technologies that you need to learn if you want to become a DevOps engineer. So this is all about DevOps tools and technologies. Up next, we are going to see real-world DevOps application with Instagram case study. And in this, we will cover below points. So we'll go through Instagram's development workflow. So Instagram is being acquired by Meta, which is a main organization who manages Facebook, Instagram, WhatsApp. This organization is managed by Mark Zuckerberg. So let's go through Instagram development workflow. So CI/CD pipeline used at Instagram. So they are making use of Jenkins or Circle CI in order to automate the integration and deployment process. Instagram developers regularly push code changes that are automatically tested, merged, and deployed without requiring any manual intervention. And as you all know, Instagram is being used by millions of users. So automation is must in order to manage the changes in the Instagram application. Second thing is infrastructure scaling. So in order to talk about infrastructure scaling, as per the blog published by Instagram leverages AWS cloud infrastructure, EC2 instances basically, to scale its system efficiently, ensuring high availability even during traffic spike. It makes use of Docker containers and Kubernetes for container orchestration, enabling fast scaling of microservices. So Instagram continuously deploy new features to the application such as Instagram stories, allowing for fast iterations based on user demand. The CI/CD pipeline ensures that the updates are seamlessly deployed without interrupting user experience. Next point is bug fixes and performance improvements. So real-time monitoring tools like Datadog and New Relic help Instagram quickly detect issues and roll out fixes within an hour. So for example, performance tuning during high user demand periods. For example, during Christmas holidays, there is a high user demand, and at that time the performance tuning is essential in order to make sure that Instagram application is live. So this is all about software development lifecycle and the need of DevOps in software development lifecycle. So by now I hope you have got a clear clarity on why there is a need of DevOps methodology over traditional software development lifecycle, and what is the role of DevOps in our day-to-day life. Understanding all these concepts are essential if you want to become a DevOps engineer. Before you jump into learning Git or Python or Ansible, understanding the basic foundational knowledge is essential to become a good DevOps engineer. So that's all for this particular tutorial. Please share this video with your friends, family and colleagues in order to get the better understanding of what is software development life cycle, and how the softwares are being created. If you want more such content like this, then please don't forget to subscribe my channel and hit the bell icon to get notified on new videos. That's all for the today's video, and see you in the next one. Take care. Bye.